So we'll start now. Okay, my name is Daniel Humeyer. I'd like to thank everyone for participating in today's webinar. I am the Business Development Manager here at Spectrum Center, and we are going to host a presentation on Maritime Mobile Ship Station radio licensing. I have with me Queenie Huang from our software development team as well. And between the both of us, we'll do a presentation that'll cover some kind of informative aspects with regards to Maritime Mobile Ship Station radio licensing, a little bit of PowerPoint, the explanation, and then we'll go into a product demonstration. So I'm going to go ahead and begin the first part of the presentation, which is a very brief introduction that talks a little bit about who we are, what we do, gives a brief overview of our company focus, and then I think a lot of you already know about our representative offices, so we won't necessarily go over that again, but we have offices around the world. I myself, Daniel Humeyer, I'm contacting from the U.S. office here in McLean, Virginia. As well as Queenie Huang. She works here at the U.S. office, but we have offices in Europe and in the UK, France, as well as Brazil, and several authorized distributors around the world that help us resell our products. So who we are, what we do, we are spectrum management specialists. Our core business focus is on the resale of our commercial off-the-shelf software product known as Spectrum E, which is a software application for spectrum management and spectrum engineering. We offer our product in two licensing flavors. We offer software as a service, or SaaS. That would be like a subscription-based option, and perpetual, which would be permanent, typically on-premise installations, are perpetual license approaches. We provide enterprise solutions and related asset building services, leveraging modified off-the-shelf implementations of adapted versions of Spectrum E. We also supply professional services. We hold a GSA multiple award schedule for professional services in areas of subject matter expertise, consultation, measurement drive testing, coverage reporting, GIS data conversion, custom software development. Those are kind of the main areas that we cover with our professional services. Most of that is provided to U.S. federal customers under the GSA schedule. We do offer this internationally as well. The rates obviously change a little bit. And we also leverage our local partners in the provision of added value services. So our core product is the Spectrum E product. It's a web application for spectrum management. It is composed of the following product modules: eLicensing, technical analysis, and remote monitoring. It is a holistic solution, meaning all these modules are integrated with each other. They're not developed separately. They don't require a series of processes or steps to import export data. So licensing data found in the eLicensing module can be easily immediately shared with a technical analysis module, or the same can be shared with the remote monitoring module, vice versa. We're going to focus today on on one aspect of the eLicensing module. We're going to focus particularly on the Maritime Mobile Ship Station licensing. We're going to also focus on the online services that this module offers. It inherently includes an online portal that allows end users or applicants, or in a regulator's perspective, their customers, to access a centralized spectrum management system. This can obviously go over internet connection, or it could be something that's facilitated maybe through a more private network. We have some customers that don't like to actually have their information exposed in any way over the internet, and so they prefer to use this system for their own internal networks. But it does leverage the benefits of a light client architecture, so you've got zero footprint, cross-platform compatibility. The system can run off of any HTML5 compliant web browser, and you get all the benefits of a centralized repository of the data, so you can easily reproduce results, you can share information easier, etc. So here, just highlighting the implementation options, you have the classic, what we call local or on-premise implementation, which can be a client-server install. As you can see in part of the diagram, you have a classic client-server installation working over a private network or intranet. And then you also have the option of a completely disconnected delivery, which would be the software installed, let's say, on a local workstation or a laptop. This is also very popular with a lot of our customers. So that's just to illustrate that there's no inherent dependencies in terms of network connectivity. You don't need the internet for the system to work. All the mapping data, everything that the system uses is all self-contained. So if you lose internet connection, it's not like, oh, well, now I can't access my my maps. No. We deliver all of that. We include all that with the delivery. So we support local on-premise installs. We also have a cloud that's typical with the SaaS offering for customers to not want to install anything. They just want to access credentialed access to the system and start doing work right away. So we have a lot of databases that we include with our system, public databases such as FCC, ITU databases, etc., that we offer. And so that's immediately available to customers that use the cloud offering. As mentioned before, it is cross-platform compatible, and we do adopt a mobile-first development policy. So you can access with any device as long as you have an HTML5 compliant web browser, which are most web browsers today, and you'll be able to use the tool. So it's touchscreen friendly. You can access it with a tablet or a smartphone, a laptop, a Mac, a PC. You'll have the same, pretty much the same user experience. And we have then the hybrid cloud approach, and this is basically a mix of the two, where maybe part of the system is installed in a local private network, and then part of the system connects through our commercial cloud. So this is kind of an option that's growing in popularity with some customers where they may not have the computing resources to support large amounts of demand onto their internal IT infrastructure, so they may leverage our cloud solution for that. But then for other things that they don't want to have exposed out of their premises, they may work with the on-site, on-premise install, or we call local install, local implementation for that part of the system. We do allow our customers to keep themselves up to date with our latest product updates, bug fixes, security patches, by giving all customers access to our online portal where they can get those latest updates. And obviously for, let's say, the cloud customers, they get those updates immediately. They don't, it's kind of transparent. They don't necessarily see them or have to have anything to do with them being installed or implemented. But in the case of hybrid cloud or local on-premise customers, they have the option to review each update and determine if they would like that update to be implemented into their local installation. And so that's offered to everyone as well. So now we'll begin with the demonstration on Maritime Mobile Ship Station Radio licensing. I thought would be a good idea to begin basically on reviewing the general need that there is for ship station radio licensing, going over some general requirements, some key input parameters necessary for applying for these types of licenses, and then finally going over how online services help address this need today. And then we'll go into how our product specifically is offering the online services. So in terms of general requirements, what is a ship station radio license? Well, whenever a vessel wishes to communicate with a foreign station, they would most likely need to get a radio license for that, for the radio equipment installed on that vessel. to communicate with that foreign station. So, for example, if a vessel needs to be equipped with a marine radio, maybe operating MF UHF band with digital selective calling or DSC, they will need to have that vessel registered and also have the appropriate radio license with the appropriate jurisdiction to be able to communicate that. So that presents an interesting scenario where you could have several external applicants or actors from outside of a jurisdiction needing to get radio licenses to communicate with the jurisdiction, maybe on a somewhat temporary basis or semi-permanent basis. This is, could be a lot of supply ships, cargo ships, fishing vessels, etc., that may be coming from different ports around the world, and they need to be able to come in and dock and unload their cargo, etc., or pick up cargo or pick up passengers in the case of, let's say, pleasure craft, luxury liners, this sort of stuff. So being able to get these radio licenses quickly and efficiently is a major need. Over time, there's been some general rules that have been established to help, address safety concerns related to vessels going through international waters or the open sea. The general architecture of the rules is described by the Global Maritime Distress and Safety System, which is basically a system that's mandated through international treaty. There's the known as the SOLAS Convention, Safety of Life at Sea, that was initially established in 1974 and been updated, I believe, as recently as 2005. And it's enforced by the International Maritime Organization, and it's basically includes a series of procedures on how shipping or vessels, basically ships should have appropriate equipment and be able to communicate with ports and basically foreign stations, radio stations. Those procedures are mostly detailed, I would say, in the International Telecommunication Union recommendations, as well as other international radio regulations. And there's also oftentimes national, in the case of the United States, for example, there's national regulations that oftentimes reflect the ITU and the SOLAS procedures. But the FCC, for example, or the NTA may have additional procedures and regulations with regards to maritime safety. So GMDSS regulations apply to, in general, to the following types of ships: either cargo ships carrying 300 gross tons or more traveling in international waters or the open seas, or any type of passenger ship carrying more than 12 passengers traveling in international waters or the open sea. Now, different jurisdictions may tighten those rules. There are some jurisdictions that have lower thresholds for a passenger ship. They may only require 6 passengers. Any vessel with more than 6 passengers they may apply the GMDS regulations. Or sometimes their requirements are additional, meaning they may say, okay, anyone with a satellite phone, even if it's a small fishing vessel with 2 or 3 people, as long as you want to carry a sat phone with you, you have to have GMDSS regulations applied to you. So that also can be controlled by the local jurisdictions, how to apply GMDSS regulations. But those are the broad requirements. There are waivers oftentimes issued to some vessels. They're usually limited to sea area communication ranges. So you have maybe some small fishing vessels or passenger vessels that are staying close to the shore that may have ability to get waivers from having to prove to be GMDSS compliant. But anything going beyond about 100 nautical miles, usually, or needing to go to any sort of international sea area or open sea area, generally is not going to be able to get a waiver from GMDSS compliance. And GMDSS compliance may also not apply to inland bodies of water, such as lakes and rivers. That may be different. That depends, of course, for each jurisdiction. So what are these ranges? How are these sea ranges or sea area communication ranges defined? Well, they're kind of well described in this diagram that I have here on the screen. So you have 4 ranges. You have A1, A2, A3, and A4. A1 is the area closest to the shore. Its definition is the area within radio coverage range of a VHF coast station with continuous DSC alerts. This is typically between 20 to 40 nautical miles. In the diagram, you see 25 nautical miles. Again, that kind of varies based on each jurisdiction. And that's approximately equivalent to 37 to 74 kilometers from the coast station. Then you have A2, and that's areas excluding A1. And sea area A2 is within the coverage range of an MF band coast station with continuous DSC alerts. So that's approximately 100 nautical miles offshore, roughly 185 kilometers. Then you have A3, and this is sea areas that exclude A1 and A2 and are within the coverage range of an Inmarsat geostationary satellite with continuous alerting. So this is basically everything between 70 degrees north and 70 degrees south latitude that's covered by the Inmarsat geostationary satellite system. So you see here in the diagram, the A3 is basically when you're getting well into international waters, open sea, and you really have no way of your radio communication system reaching shore. So you really will depend very much on satellite communications. Then you have A4, and that's basically area completely excluding all the previous areas described before. And these are the north and south polar regions, basically north and south of 75 degrees latitude. And so that can also be any other areas where coverage is provided by the polar satellite system known as COSPAS SARSAT. So it's a different satellite system. And here in the diagram, you can see that A4 is way far away. It's up to the polar regions, but A3 pretty much is international waters, open sea area. So you have different types of systems to communicate with distress vessels that may appear in there, but they all depend very heavily on communicating with a satellite that would then maybe communicate with a patrol vessel that could then locate the distressed ship using different devices, which we'll discuss, such as search and rescue transmitters or EPerps. We'll talk about that in a little bit. And then as you get closer to the shore, then you have coastal stations operating in the MF, HF band or VHF band or UHF band that could help identify vessels that may be in distress. Those would typically be obviously smaller vessels in many cases. It can be large vessels that are approaching or are leaving port. And there's a whole system, of course, of supporting that information and confirming, what the vessel is, identifying the vessel. We'll talk about that and how that's done in a little bit. So key parameters. So in order to support this system, there are important parameters that must be included with any ship station licensing application. We're going to go over some of the key ones and mention a few others, and we'll kind of go into details as to how those parameters were established. They help identify vessels and communicate the information of those vessels to search and rescue teams, and then help identify their location as well. And these parameters are pretty important. They must be either input into any type of application, or they must be generated by a system that is handling ship station license applications. So we're going to go ahead and begin. The first is the IMO Registration Number. Stands for International Maritime Organization Registration Number. This is a unique identifier for ships and ship owners assigned under the SOLAS Convention, generally attached to the hull of the ship for the entirety of the vessel's lifetime. Here's an example on the right. You can see the IMO number on this cargo ship. It consists of a 6-digit sequential unique number followed by a check digit. The check digit verifies the integrity of the IMO number by multiplying each of the first 6 digits by a factor of 2 to 7 corresponding to their position from right to left. The rightmost digit of this sum is the check digit. So that's a field control that needs to be applied to any system that would be taking ship station license applications. So this ability to check if the IMO number is valid is something that a system should be able to do. Currently, I believe the IMO registry is managed by the International Handling Services Market, formerly known as IHS Maritime or Lloyd's Register Fairplay or IHS Fairplay. This is kind of a large company based out of London, I believe, that holds or stewards the registry of IMO numbers. I think they do offer a web service for doing this checking, but I think it's mostly offered to regulators, or it might be offered for a fee to the public, but I have to double check on that. We are trying to interface with that. Actually, that's something we're working on to kind of automate the checking of the registration number to make sure it is actually registered in the IHS market. But our system for now, it does do the algorithmic check to make sure that the IMO number is kind of a valid number. A comparable system known as the European Number Identification or ENI is used for European barges and inland waterway vessels, and that's a unique 8-digit identifier. We won't go too much over ENI today. We'll focus mostly on IMO registration as one of the key input parameters. This is an example of how the check function works. So you have the 6 digits and the check digit. So 907472 are the 6 digits. The check digit is 9. You multiply each of the 6 digits in kind of like a descending order. So you would go 765432, and you would get obviously some results, and the final value in that resulting value must match the check digit 9. So that's kind of how the check works. Pretty simple. Not too hard to implement, but systems that do take in these types of license applications must be able to check this. Then you also have the Maritime Mobile Service Identity, or MMSI value. This is a series of 9 digits transmitted over a radio channel in order to uniquely identify ship stations, shipper stations, coaster stations, and group calls. The initial digits of an MMSI categorize the identity as defined in IT recommendation M585. So the first digit means the following. So a 0 would generally represent a ship group or coast station or group of coast stations. A 1 is generally not used, or it's reserved for search and rescue aircraft, or maybe Inmarsat A systems. 2 through 7 represent individual ships, and that's usually the beginning of a 3-digit, what's known as a Maritime Identification Digit, or MID. So the MID will start with any either a number from 2 to 7 that kind of corresponds to a specific region. So here you have the detail where 2 represents Europe, 3 represents North and Central America, as well as the Caribbean. 4 is for Asia, not including Southeast Asia. 5 would be for Oceania, Australia, New Zealand, as well as Southeast Asia. 6 is for Africa, and 7 for South America. I have here an example of the table of MID values and the corresponding nations or jurisdictions that they respond to. So you have here like 3, 4, 5 is Mexico. As mentioned here, 3 represents North America. In some cases like the US, you'll have several. You'll have 366, 367, 368, 369, as well as 338. And that's because these values do start to get exhausted over time. So there's additional, once I believe there's about roughly 80% exhaustion of the MID code combinations. additional MIDs are assigned for those territories. So U.S. has a several. I think UK has several. Panama has several due to all the amount of supply ships and cargo ships that go through the Panama Canal, and other areas with lots of vessel traffic may have multiple MID codes. Part of the the MMSI value can be used by telephone systems to call ships automatically through general telecommunications networks. And you also have 8, and that's usually for handheld VHF transceivers. 9 is reserved kind of free-form, so it can be search and rescue transponders where they have a particular prefix, 970 start, or some DSC AIS systems would use 972. EPerps fitted with an AIS transmitter will go 974. Tandem vessels may start with a 98 before the MID, or navigational aids may be 99 before the MID code. Here's an example of registration of an MMSI into a ICOM marine device. Here, I believe this is an EPerp. So you see here the code is entered and it's representing the UK. It's the MID for the UK. And this is important. This information is usually a output of a ship station licensing system, and in our case, that is the case as well. And so that will be then given to a licensee, who will then take this information, take it to the dealer or manufacturer of their EPROP device, which is oftentimes required for vessels to go out into open sea. That's a kind of a distress beacon, and that MMSI value is then programmed into the EPerp device, so that the EPerp device will then produce a hexadecimal code that can then be registered or reported back to the regulator, who will then register it into a centralized database system, which we'll talk about briefly. So that's an example of the MMSI being registered into this marine radio system. There's 6 kinds of maritime mobile service identities. There's ship station, group station, coast station, group coast station, search and rescue, aircraft, navigational aids, and tandem vessels. Tandem vessels are basically vessels that may accompany a larger vessel, such as luxury liners that may have additional smaller vessels that accompany it. So in those cases, they would have separate MMSI codes that'll have some similarity to the parent vessel's MMSI code. So for ship stations, this is what we're going to focus on today. We're not going to focus so much on group station or coast stations or group calls or anything like that. But for ship stations, you basically have the MID, which represents the jurisdiction, the country that the ship is coordinating with. And then you have 3 digits that can be anything from 0 to 9. And if the ship is outfitted with an Inmarsat B, C, or M ship Earth station, or has to communicate with such an Inmarsat system, then the identity will have 3 trailing zeros. So I have that example here on the right. We have 367-949-000. The 367 is one of the MID codes for the US. 949 is the value that's assigned through whatever system is assigning the MMSI, like could be our system, for example. The 000 will then designate if that is an Inmarsat ship Earth station. If the ship is fitted with an Inmarsat C ship Earth station, then the identity may only be 10. In 1997, the WRC Resolution 344 did address the exhaustion of MMSI numbers. So previous restrictions for Inmarsat B or M ship Earth stations may no longer be applicable. All 9 digits of the MMSI can be used in cases where MMSI resources has been exhausted and no longer need to end in trailing zeros. So this is also being kind of overwritten in certain cases where you do have MMSI numbers being used up. So here's the it's kind of same idea. This is how the other types of MSI call identities are structured. For group ship stations, you'll have a 0 and then the MID. For coast stations, you'll have 2 zeros, then the MID. For group coast stations, you'll have 2 zeros in the MID. That's for any coast station using the MID, or you'll have 0 and then 2 zeros and then 9999, and then zeros. This would be for VHF coast stations. This for then you have for search and rescue transmitters like 970. Where the 2 Y characters are signed by the International Association for Marine Electronics Companies, and they'll refer to the search and rescue transmitter manufacturer, and the X's are sequential digits assigned by the manufacturer identifying the SART, the search and rescue transmitter. Now we'll talk a little about the EPerp. EPerp stands for Emergency Position Indicating Radio Beacon. So an EPerp is a portable battery-powered emergency radio transmitter used to locate vessels in distress. In the event of an emergency, the EPerp transmitter is activated and begins to transmit a continuous radio signal. The EPerp signal is used by search and rescue teams to quickly locate the emergency and render aid. The signal is detected by satellites operated by the International Consortium of Rescue Services known as COASTPAS-SARSAT. COASTPAS-SARSAT satellites can detect EPerps anywhere on Earth, transmitting at, I think there's a few different frequencies. I think there's a VHF and a higher frequency, but typically I think, at least in the Western Hemisphere, it's usually 406 megahertz. The MMSI value is used to program the EPerp device and generate the appropriate EPerp registration number. That's the hexadecimal value that I mentioned earlier. And the EPerp registration number must be reported to the local regulator, whom in turn registers the EPerp in the International Beacon Registration Database, or the IBIRD. So that is usually done through a variety of web portals. In the Western Hemisphere, I think the most popular one is 406registration.com, but I believe there's several portals throughout the world. This information is registered. We are in communication with the developers at 406registration.com and that steward the IBIRD, and they have been saying they are going to facilitate a degree of automation to be able to communicate this information to the IBIRD in a more automated way. Right now, unfortunately, the regulator has to manually re-enter everything about the vessel and the EPerp back into the IBIRD database through their separate web portal. But the idea would be through a system such as ours to automatically report that. I think they are facilitating fairly soon a file upload capability, but the idea would be to have machine-to-machine communication accomplished through a web service. So we believe that in 2022 they will publish their API, and we will be able to implement an automated level of integration with the IBIRD. And this diagram here on the right kind of just describes how the process works, where you may have a distress call. Basically, the ship may be sinking or goes into the water. It kind of automatically activates the transmission with a continuous kind of call, selected call there. That's picked up by the search and rescue satellites, the COASTPAS-SARSAT system, and then that's communicated to a coastal station that is then passed to mission control, rescue coordination, and that's how the coordination effort is initiated. So there could be a vessel sinking in the sea, or it could be an aircraft that may have crashed. Both would use kind of the same distress calling capability. There are several other key parameters typically required for ship radio station license application. These include call sign, vessel name, ship type, which is an ITU code, gross tonnage, number of passengers, vessel length, radio operator details, accounting authority details for vessels equipped with satellite phones or satellite or shipper stations, ship registration numbers, additional attachments or custom fields that may be required for different jurisdictions. So our system can does accommodate these other parameters. Some of this feeds into the billing process. Sometimes there's different fees that are charged depending on the ship type, or some fees are based on tonnage or passengers or vessel length. So our system can take any of those parameters and tie it into the rest of the eLicensing module's capabilities, such as its billing capability and so forth. So there is an online payment capability that we support and we offer. We can also integrate with customers' merchant account services and payment gateways if they have that already set up. But if they don't, we do offer an alternative where we can offer essentially a parallel merchant account service and gateway to a customer that would like to enable credit card payments, for example, or other types of online payments for these types of licensing efforts, which is a big help when it comes to things such as ship station radio licensing, because as mentioned before, if your jurisdiction does have a large port, you may be getting ships coming in from different ports, international ports all the time, 24/7, and there may be bottlenecks where you have just a number of applications coming in and you have difficulty processing them locally with maybe antiquated tools, and being able to process, doing simple things like process online and paying the fees online and things like that. Surprisingly, this capability is not enabled with a lot of regulators. So they'll get several ship station radio applications and be pressured to process them in a short amount of time, which then consumes a lot of their resources that they would like to use for other purposes. So our tool does offer this ability to automate a lot of that, and we'll kind of highlight that today. So here we have Spectrum eLicensing web portal, online payment gateway support. So this is kind of the general workflow of how this works, because there's the frequencies here are all kind of pre-allocated and coordinated with ITU depending on regions. There isn't as much of a spectrum engineering analysis need, but it's more of a kind of a application processing and validation that's necessary. So trying to make sure that applications aren't filled out incorrectly, that critical inputs are filled out correctly, required fields are filled out correctly, information is consistent with what's supplied in other other registries. That sort of stuff is obviously where the value of our platform kind of comes in. Well, one of the major values, I would say. So our eLicensing module does include an online portal, so where applicants can self-register and prepare and upload applications for maritime ship station licenses. We offer integration with online payment gateways to support credit card payments. Our billing module takes into account the appropriate parameters such as license duration, ship type, gross tonnage, etc., to calculate the ship radio station license fee. Our system does include a field control validation feature that helps ensure that the required information such as IMO registration number, accounting authority details, etc., are captured in the ship station licensing web form and captured correctly prior to submission to the local regulatory authority. So this kind of puts more of the onus on the applicant to get everything correct, so that when the regulator receives the application, it can either be processed fairly automatically, or it's much easier to process. It's not as tedious and time consuming to check every field and make sure that everything was entered correctly in the application. Can include also a checklist to aid end users in confirming if required attachments or other applications specifics are supplied with the application. We do offer the ability to generate the MMSI number and call sign in accordance with IT recommendations. The workflow manager supports adjustments to a regulator's workflow for any licensing certification process included with the system. And the system can receive, validate, and authorize or reject incoming applications in an automated or semi-automated manner. The corresponding certification or license can be auto-generated upon final approval, and related fees are collected via online payment portal or check, wire transfer, or cash payment. So we'll start the demonstration here. So I'm not going to go over this entire process in this particular portal. This is just a sample portal using a test account, so you guys can see it is online, it's working. An applicant that would want access to this particular portal, which is the British Virgin Islands example, would click on request access. They would fill out this information, and there's a validation process that would follow that would then confirm them via email, as a valid user. They would create credentials. We also have the ability to support things like one-time password as well, to give the applicant the ability to self-register and begin to work with the system without having to require the involvement of the regulator, for example, to help them get access to the system. So once that's done, I'm not going to go through that whole process because it takes a few steps, and it's easy, but it's just to save time. We're going to already assume that the applicant has created their profile and they can access the system. They can log in, and they'll see here in this case it's very kind of limited access that they have. They only have, in this case, access to this option for maritime and a few other features. They have a user profile where they can change some of their details. So there I could change, let's say, my contact information, etc. I have here like a identifier. I can view my ID here. This can all be obviously tailored to a customer's needs as to how they want to manage user profile details. And there's a few other little goodies here, such as calculators or viewing the spectrum allocation chart. But the main thing we'd focus on is this maritime option. So it makes it a little intuitive, relatively easy to know how to use this tool, because we don't overbear the external user with too many features, and we can always control what we allow them to see. So in this particular case, this applicant, I've been testing this out. So you see I have a number of applications here in my applications bin. I can look at this table view. If I, let's say, want to filter anything, let's say I want to filter per state. I want to see only my applications that are in coordination, for example. I don't have many that are in coordination, but if I had, let's say, several, I could enter in a filter there. I can all combine filters. There's a simple syntax to learn to kind of combine filtering criteria in this table view list. I can also, if I want, toggle the view. In this particular desktop mode, it's not as important, but if I were working with a touchscreen interface, let's say a tablet or even a smartphone, this block view is maybe a little more convenient for viewing the information. So it's a nice little toggle feature there, compatible with different types of devices. And I have a licenses option here where I can see what has already been issued, and this is only for my account. I don't have access to other people's licenses in this account, in this case, right? So if I want to generate, let's say, the license document, I click on generate, and it'll create the license with a QR code, an issue date, an expiration date, and a number, and has all the details here with the license. This is the legal information, some of the technical parameters of the ship station, such as MMSI, IMO, and then if I need more additional details about the actual radio equipment, I can generate a tandem certificate that here contains like the specific equipment details, like the model number, frequency, power, equipment type, etc., associated to that particular ship. So all that I can see is for previous licenses. I did prepare a draft application here, so we're going to look it over real quickly. So this is like the cover page where the applicant would specify a desired issue date, which I've set for tomorrow, a license period. Again, these can all be customized. Our customers sometimes require different license periods, so don't feel anything here is necessarily fixed. This is the applicant that I was preparing, Malta Shipping Company. And this is kind of the cover page. There are field controls here. For example, if I forgot a required field, the system would tell me, hey, you forgot the city. Okay, so then I'll enter that in, and it won't let me submit the application until all the required fields are entered. So I'll save that, and then I can go into the associated radio equipment here. So I've got here some ship station information. So here I've filled out some of the information regarding this equipment that needs to be registered to the ship. And this is the name of the vessel, call sign, IMO number, the sea areas that are corresponding to this vessel, where areas they want to travel in. This form adjusts itself dynamically depending on how some of these options are configured. So for example, if I did not pick A3, some of these options related to satellites, like they would not appear. It would automatically select no in this question if the vessel is equipped with satellite phone, and these options for radio traffic accounts and Inmarsat service providers, all this stuff would go away. Satellite or station options, all that would go away if I did not check A3. So it's kind of a dynamic feature there. You also have the ITU ship types included there. So some of these options can also be kind of tied together, where if, let's say, I were picking a pleasure vessel, then the options of the type of ships would be changed to only be restricted to pleasure vessels. So there's like, if I pick pleasure vessel, I wouldn't necessarily be able to then pick a trawler, because it's not really considered a pleasure vessel. I'd be restricted to the ship types that are like pleasure vessels. So there should be like cruise ships, escort ships maybe, or things like that. I enter in the gross tonnage, ship length. This is already just inputs. Then you have here the option to define the provider details for, in the case of satellite phones or satellite or station phones. You can put in who are the providers. In some cases, the regulator may also ask for evidence that there is a service that has been subscribed to with these satellite service providers or Inmarsat service providers. In the case of registering satellite ship earth stations, you would then have the ability to add those details here and add in as many ship earth stations as you wish. If don't need that many, you can just remove them. Radio operator details, this is typically a prerequisite. So usually you need at least 2 radio operators, I think. So I'll just put another one, test user. I'll say it's just an example, but that could be also a requirement, is at least 2 radio operators and their license numbers are entered. And then that could also be requested, like their evidence of their certifications could be required as an attachment. Here we add in the different equipment. You can pick here from a drop-down menu the list of equipment, enter in the appropriate details. So here I have a VHF DSC radio, I have an MF DSC and NVDP radio, an HF radio, and a SAR-T, search and rescue transponder. And then I have here some details about the EPerp. NICOM EPerp at 406, can also be 121.5 or 1.6 gigahertz. Here's information about the ship. This is usually a local requirement. Is the ship been registered at the local registry? If yes, you'd enter in the registration information and maybe a copy of the registration certificate. If no, then there may be a different procedure executed, maybe a check with the local registry if the application's been submitted or not. So in this case, if everything looks fine, I will just go back to the application page and click submit, but it's telling me my IMO number is invalid. So that's interesting. So I'm going to go ahead and go back into the ship station details, and we'll go to the IMO number, and here we have this. So the check digit here is the 6. We can do the math and try and figure out if this is appropriate or not, but I already know it's wrong. I already know that this is actually the same example that was used in the PowerPoint here earlier. So I'm using actually this example here. So I have here 9074729. So the check digit 9, it must be 9. It can't be 6 in this example, because the calculated value will end in a 9. So that's why it wasn't working. So I'm changing this to 9, and then I'll save. And we'll go back to the application here and then submit. And then it's going okay, and there's going to be a process where I have to accept terms and conditions and then pay. So we're not going to go through the payment on that because we don't want to disturb. It's an actual, even though it's a test account, it is a live system, so we just want to kind of highlight how it worked. We're going to now transition to Queenie, who will show how the online payment can work, and then go with the second step of the process would be receiving the application from the regulator side and processing it. We won't use this portal anymore. We're going to use a generic test portal, but we'll use the same example. So with that, I will disconnect my screen display, and Queenie, whenever you're ready, feel free to start.
Okay, so hope everyone can see my screen.
Yes, I can see your screen.
Is the size okay? Like, do I need to enlarge or?
I think it's okay. It's right about the right size.
Okay, good. So I'm in an applicant's account and I have already prepared an application and I'm ready to submit this application. So when I select this record, I can submit and it will take me to the payment page where I can make the relevant make payment with my credit card. This is connecting to payment portal's test account. So this credit card number is the test number. If I put any other card number, it would not allow me to proceed. So the payment would not go through. And so after I fill out my credit card number and I have the terms and condition also in this page. And after I read through the terms and conditions, I can accept and complete the transaction. So my transaction has completed. I can go back. So after the transaction is completed, the application is submitted to the regulator. So the applicant's work is down for now, and I will go to a regulator account. So for manager from the regulator, the page we have access to more capabilities in the system. We have access to the map. And I will go to the Maritime Module. And in the Maritime Module, as a manager, I also have access to organizations and some settings. And I can see a list of pending applications in here. So if I select one of the record, I can choose to pick up this record. This is when multiple managers are working on the processing maritime applications, and when they pick up, it will suggest that I'm already working on this application. I will take it through the process and I'm already working on that. So is able to tell other managers that this application has already been processed. And we also can allow directors or to assign each application to the officers. This is for managers to self-assign the applications, to pick up the applications. So after I pick up one application, I can view the relevant radio stations in there. And so I'm like reviewing, this is the form that Daniel has just showed. And I have like the manager can review the information inside. And after that, the manager can decide either if there is any incorrect or missing information, they can decide to reject this application. But if everything is right, then they can approve the application. So I'm just go ahead and approve this application. And the manager can like update, change the issue and expiration days here. And then when I click save, it will approve that application and it will become a license. So this is the record that has just been approved. And we are viewing the radio station inside. The manager has the ability to sign the certificate, which is to attach an electronic signature to the license. And after that, the license would be available for downloading from the applicant's side. So let's go ahead and sign certificate. So it like the state here suggests that it's certificate signed, and at this state, the certificate is available to the applicant. So we can go back to the applicant's account. And we can take a look at the certificate. And also after the license is approved by the manager, the MMSI and the call sign would be assigned to this ship station. And we can download the signed certificate. So we have the information about the ship and the radio equipment listed on the certificate, and we have the electronic signature in the certificate. And after the applicant received the MMSI and call sign from the regulator, they can bring this information to the supplier of the EPerp device, and they will receive a hexadecimal code for the EPerp equipment. And let's go back here. So we have this register EPerp button here. When they click, it will take them to this form where they can fill out some information about the vessel and also most important, the hexadecimal code for the EPerp device. So let me just go ahead and fill out this form. And the form has some business rules where it's checking the validity of this hexadecimal code for the EPerp device. So for example, if I like accidentally put like the incorrect code in here, it will say that like the country code encoded inside the COSPA star set code is incorrect. So it has some checks inside the system. And so because the country code is just the MID code for the country. So it's checking that in the system. And after it's no error, I save this. This is for this registered EPerp would be the applicant like fill out the hexadecimal code for the EPerp device. And after that, the regulator would be able to report that hexadecimal code to the IBRD, the database for the rescue beacons. So let me go and see the ship station that has been approved. So here you can see that the EPerp code is registered, and for a manager on the regulator side, they can download the Mars notice. So the system will generate Mars notification in a text file that's in the right format and with the relevant information in there, so they can report, they can upload, like send this to ITU for reporting purpose. And yeah, so after that, the regulator would report the EPerp code to the IBRD database, and that's the end of the process. So that's all I want to show, Daniel.
Okay, thank you very much, Queenie. I'm just going to highlight a little bit about the registration. So this is the I think this is for North America. This is the COSPA-SARSAT IBIRD registration portal. It's generally restricted to regulators. So you have to have credentials to access it, but this is where you would register your EPerp devices. This is hopefully in 2022, excuse me, going to become an automated process with our system, where we'll be able to automatically report ship vessel data and EPerp data and the hexadecimal value through a web service call. I think there were some questions regarding the communication channels. They're generally 406, I think, for EPerps. I do think they can work at VHF bands. They do support some I think a particular VHF channel, and also I think there's 1.6 gigahertz as well. But the specific allocations are reserved. There may be regional differences as well. But I think that's generally well coordinated. But in terms of these types of distress communications, they do need to support data, and they're generally working in the UHF band when they're going into A3 and A4. They're generally working in the UHF band, I'm not sure if they work lower than that, but yeah, that's usually about the frequency band that they're working with. They generally communicate with satellites. I think there has been some experimentation with HF band because HF can go out into A3. But I think the U.S. Coast Guard, we will work with the U.S. Coast Guard a little bit on testing HF networks and communication to A3, international waters, etc. I don't know if that's ever been fully put into operation though, but satellite seems to be pretty standard.